In this video, we're going to very quickly talk about determining IMA for wheel and axles because they act a lot like levers. So pay very close attention to what the wheel and what the axle is and how that impacts your effort force and your resistance force.
Now, if we look really closely at a wheel and axle, essentially what it is a lever arm that's allowed to continuously rotate all the way through. So our measurements kind of derive from that as well. So if we imagine the center or the axle as the fulcrum of a lever, they're going to act in essentially the exact same way. And that's going to show us how to do our measurements. So when you are measuring for your effort distance and your resistance distances, you're always measuring from the center part, the axle, to the outside edge. So you are figuring out the radius of your circle. Now, if we flip it around and look at the axle itself, let me kind of zoom in there, you'll be measuring from that center part to the outside as well. Now, notice how you're going to be dividing your effort distance divided by your resistance distance anyway. So really, you can use radius or diameter as long as your measurement is constant. So if I use diameter to measure my wheel, I need to use the diameter to measure my axle. Now, one really important distinction that we need to make for wheel and axles is what is driving what? Is the wheel driving the axle or is the axle driving the wheel? Typically, we call the smaller one the axle and the larger one the wheel, but really that nomenclature doesn't matter that much. So let's do kind of a quick calculation to see exactly how this works. So I've already measured my wheel and axle, and I found my wheel to have a radius of 20 centimeters, and I found my axle to have a radius of 0.5 centimeters. So let's say there's a problem that's telling you to figure out what is your IMA if the axle is driving the wheel, meaning my effort force is turning the axle, which in turn turns that wheel. So if we have our effort distance, which is 0.5 centimeters for our axle. Our resistance distance is 20 centimeters, or the radius of our wheel. When we divide that out, we find our IMA is 0.025, which is really, really small, which means I need to apply a lot of force to overcome that resistance, but notice how just a few little twirls, that distance is huge. That speed is really, really fast. So there may be situations when, even though the force isn't being multiplied, your distance or your speed is. Now let's flip it around the other way. Let's say that the wheel is driving the axle. So now my effort distance is the wheel itself, and my resistance distance is the axle. So if we divide our 20 centimeters by 0.5 centimeters, we come up with an IMA of 40, which is a huge force multiplier. So thinking about like a steering wheel, you don't have to do much force in order to get a lot of bang for your buck out of the axle. But notice I have to turn this wheel a lot in order to get one rotation from the axle. So keep in mind that wheel and axles act a lot like levers, where we're measuring from the center to the outside to find the radius, or the diameter, as long as you're keeping it consistent. And you always have to keep in mind what is driving what. So the thing that you are putting force into, that is your effort distance or your effort force.